Hi YouTube, I hope you all are having a wonderful weekend. This is Abraham Moeller, and today I'm excited to share with you the second part of my review of the Digirule 2U microcomputer trainer and digital ruler. The first part of my review that I shared with you back in September was about the device itself and how you can load programs on it by entering them in through the front panel switches. But this second part of the review focuses on this little bit here, the USB-C interface, and more broadly, how you can interface the Digirule 2U with a PC and what tools exist on the PC for developing software on your Digirule 2U. So to start, I'm going to talk about the built-in programs on the Digirule 2U that communicate with a computer. A couple sample programs that demonstrate serial connectivity, and secondly, the Debug Monitor that you can use to take a look at memory as well as registers, and in addition, step through programs. And then after that, I'm going to talk more about the PC side, what tools exist on the PC to assemble programs for the Digirule 2U, and what other utilities exist on the PC, say to transfer programs to your Digirule 2U or receive them from the Digirule 2U. So let me get started with those two sample programs demonstrating USB connectivity and serial connectivity on the Digirule 2U. Let me go ahead to sample programs, and we can see some that I had demonstrated in the first part of the review, like the Kill the Bit program. But the two we're interested in here today are Hello World, which doesn't just show Hello World text, but something much more beautiful that I'll leave as a surprise for a few more seconds from now. That's in the non-volatile storage at position 0, and then an Echo software loopback program that my cat's very excited about in position 6. This not only will take any data received on the terminal and transmit it back, but also show the ASCII codes on the data LEDs. So with that, let me go ahead and get started for showing those two programs to you on the terminal. And my cat's very excited about that. Let me go ahead here and switch over to the terminal and switch tabs here in the terminal to the one I was using. I had gone setup here earlier. I'm using minicom as my terminal emulator, and that's set up as 9600 baud, 8 data bits, no parity, and 1 stop bit. Okay, so go ahead and load that up here and show you those two programs. So as I discussed in the first part of the review, to load one of the programs in non-volatile storage, I press load, and then the number of the section of non-volatile memory that contains a particular program. Let's start with Hello World in position 0. You can see the LED moving, the LEDs turning on and off back and forth, and I'm going to go ahead and press 0, and that's loaded, and I'll go ahead and run that program here. Okay, make sure that's connected here. Yeah, there we go. Okay, so you can see Hello World not just printed as text, but as ASCII art. Very beautiful block letters in a continuous loop. That's just demonstrating serial output. So I'll go ahead and go through a few more of those, and then stop this, and then load the program in position 6, which is that Echo Test software loopback. I'll press load again, and then D6, and run that. And now I should be able to type in characters, and they're repeated to the display. And what I'm going to do is hold the Digirule 2U up to the camera so you can see what happens when I type in different characters. Watch for those data LEDs there at bottom right. Okay. You should see those changing with the ASCII codes of 1, 2, 3, 4, 5, 6, 7, 8, 9, 0. Let me just do one more and make sure that it truly changes. And it did. Okay, so that's good. That worked. So that's just two sample programs that demonstrate serial output for the first one, that Hello World program, and then serial input and output for the communications loopback. What I want to show you next is the Debug Monitor. But before I do that, I'm going to switch windows back to the manual to see what features the Debug Monitor offers and how to get in that mode. There we go. So we'll go ahead to the Debug Monitor. Okay, so this built-in Debug Monitor has the following functions. It has several different ways you can manipulate the volatile storage as well as non-volatile storage. You can display registers, edit several specific registers such as the accumulator, program counter, and breakpoint. And then you can finally run and stop your program or single step through it and reset the CPU. To start the monitor, I'm going to make sure the Digirule 2U is in stop mode. I'll press and hold the load button and then press the store button. So let me go ahead and do that. Okay, so, and before I do that, switch windows back to the terminal here. Okay, so press and hold load, or wait, first get this in stop mode. So I pressed run stop. Over there on the right for you viewers, and I pressed run stop to get that stop. I'll press load and then store, and boom, there we go, Digirule 2U Debug Monitor. I can display memory there. That should have our loopback program. I can disassemble the memory. This is pretty cool. Yes, why not? Default program counter. And you can see the COM in, COM out instructions plus a loop jump back to the third byte there. And again, so you can take whatever's in memory and then see the mnemonics that correspond to the bytes that are present. Let's go back through the options. I'm not going to go through editing and filling memory. Let's take a look at the registers. You can display those different registers. Program counter, status register, the accumulator, stack pointer, and then whatever's pointed to at the program counter. So that instruction is common. We can run the program and also step, I guess not here because of the, I think because the program interferes with the serial interface, and of course we're using the serial interface here to run the Debug Monitor. You can reset the CPU. Oh wow, oh that's interesting. Okay, I've reset back to the zeros, the program counter back to 0, 0, and step through. And that's pretty much it. So those are the different features offered by the Debug Monitor. This is great because you can edit what's present in memory and then step through a program and see the outcome of it in the address and then data LEDs. Okay, so those are the programs built in on the Digirule 2U that involve PC communication, and just demonstrate in those first two programs how you can communicate with PC, and then in the third program let you debug the Digirule 2U itself from the comfort of your terminal emulator. So from that, I'm going to switch over to programs that you can run on your PC to develop software for your Digirule 2U and also to communicate with it. Send those programs over to your Digirule 2U. Okay, so for that, I'm going to go ahead and switch over to the user manual and then to the manual for the ADR2 cross assembler as well as GitHub. So the place to get all these programs is in the Brad's Projects Digirule 2U repository from Brad Slattery and Brent Hauser, who developed this fine device. And what you want to do is clone this into whatever directory you want. So I had this cloned into my home directory. This includes manuals for the Digirule 2U, the ADR2 cross assembler, the DLDR2 download utility, which I believe is just for Windows and Mac, not for Linux and Unix based systems. And then the UDR2 firmware updater, which I won't demonstrate since I'm pretty confident there's just I just saw one firmware file present, and my Digirule 2U has that version firmware. You can see there's also a bill of materials, information about printing the circuit board with the traces for the Digirule 2U. But the most important things for us are the software tools, the assembler, download utility, and firmware updater I mentioned, and then sample programs, which you'll notice correspond to those already programmed into non-volatile memory by default on the Digirule 2U. Your Digirule 2U will come with these programs in those 8 different non-volatile memory positions. Okay, so let me go ahead and switch to the cross-assembler manual. That's the first thing I'll go through. This is a very nice tool that will convert assembly source into machine code, listings, and Intel hex files that you can upload to your Digirule 2U. You can go ahead and develop a program in the instruction set, which happens to have a reference on the back of the Digirule 2U itself. There's some information about it here, how you run this in the assembler. You input a source file and then output a hex file. You have several different options here that you can see when you run this help subcommand. And note that not only can you output a hex file, but you can even pipe this out to TTY USB 0, the USB serial interface of the Digirule itself. So let's go ahead and do a demonstration of that. Let me switch windows again to the terminal window, the terminal there. And I'll switch to sample programs and show you how I can cross-compile. The example I'll use is kill the bit, and then I'll show you how that runs on the Digirule 2U after uploading it. Anyway, so I'll go ahead and run this, and if there aren't errors, as there shouldn't be, you'll just see assembly complete. Digirule 2U cross-assembler, December 18, 2020, KD0GLS, and no errors that went through there. Again, the command structure involves me piping in the assembly source, outputting a listing file, and outputting a hex file. If I go through the assembly source, you can see that this is structured into into this loop and a start subroutine, and you can see the registers that are referenced as well as the mnemonics. When we look at the listing, this provides even more information. We get the whole assembly source, but also the machine code that corresponds to that, which you could enter in by hand with those buttons on the front panel, plus the different subroutines and then registers that are present, and then the RAM that's used. Not that much RAM on a device that already doesn't have much RAM, just 256 bytes. Okay, so now what do I want to do? I want to upload this to the Digirule 2U itself. So to do that, I need to pipe it out to TTY USB 0, but on my system, because that's owned by root, I need to execute this with bash. So what I will do before I run this is get my Digirule 2U in load mode. So I will press, I'll go to load here in this file section of the device itself. Get this in, I'll press load. Yeah, I had to get that in stop mode. Load, you can see the the light moving back and forth along the data LEDs there. And we'll press load and then next. And now we should see D7 there blinking. And later I'll go ahead and show you the part of the manual that describes the status LEDs for loading and saving programs from a PC. And now that I have that in load from USB mode, I will load the program from USB. And we should see that the blinking light is no longer blinking, and there's another light that's solid there. Okay, so now let me go ahead and get this back in run mode. And now we can really confirm that I uploaded kill the bit. You can see the bit moving across those LEDs. And again, the way this game works is you want to press the button corresponding to where the bit is in order to kill it. If you don't, you might make more bits that you have to kill. Simple 1-bit fun game. Anyway, so the point of that was to confirm that I could load a program from my PC to the Digirule 2U's volatile storage. Let me try now downloading this program. I'll get this back in stop mode. Let's get that in stop mode here. And try saving a program from the Digirule 2U to the PC. Okay, so to do that, I'll go ahead and open a pipe and then save that in the file test.receive. So I have this pipe open, waiting for any content from the USB serial adapter to enter that file. Okay, so in order to do this, instead of pressing load and then next, I'm going to press save and then next. And let me go ahead and show you what the LEDs do when I... So you saw that the Digirule 2U went through all its addresses, and then now that it's done, you see two solid LEDs present. And I can press Control-C to close the pipe here, and both look at the size of that. You can see 585 bytes saved. And I can use XXD, the hex editor, to see what's present, and this should be in Intel hex format, which it looks to be. Okay, so that's saved. Now what I will go ahead and do is show you the manual with a little more information about those load and save modes, and finally wrap up my presentation. Okay. Yeah, so I have that up. Okay, so I'll go back to the user manual. I want to take a look at com save and com load. Okay, so in com load mode, RAM is loaded in Intel hex format from the COM port, that USB serial adapter, and the address LEDs show a progress bar. So D7 is blinking the data LEDs, and then if there's any issues, these error LEDs will start blinking. D2 if there's a problem with record type, D1 if there's a checksum error, and then D0 if there's a non-hex character that's present. After a file is loaded, the Digirule 2U automatically resets the CPU, sets the program counter to the entry point of the program, and enters stop mode so you can run the program. In com save mode, D6 it shows up as blinking, and then once data has fully been transmitted, the talking LED stops blinking, and the Digirule 2U enters stop mode. Okay, so I think that wraps up this second part of my review of the wonderful Digirule 2U microprocessor microcomputer trainer. I really love this device. I mean, I also have the Nano Canback 1, which is a similar form factor, and unlike the Digirule 2U, it's replicating a known existing system, the Canback 1, developed by John Blankenbacker. But I really like the Digirule 2U a lot more. I mean, it's more intuitive to use, the buttons and the way the panel's laid out. And it has a USB port that you can connect to a PC, which opens up a whole new world of possibilities. You can use a cross assembler, you can save data output. And then even beyond that, one thing I think I had talked about is there's this extra expansion next to the USB port that lets you interface, real live devices in there. You could even do some kind of data acquisition with this. You can see those pads that you could solder to. I love the device. I give it a glowing review. I can't wait for Brad and Brent to release a new batch of these devices, so those of you who don't have it at home can get this and see all the fun you can do just on the power of a CR2032 cell battery. One little coin cell battery, so much fun, very wonderful device. Anyway, thank you all for watching. Please like and subscribe to see more computing and biking videos. And if you have any questions or comments, leave them down in the comments below. Thank you all for watching. Take care.